Wait, what? That's not what the derivative of the inverse sine of x is. I forgot the radical. How ridiculous.
I hate the radical.
Well, just, that's on the screen, isn't it? I can actually change that. Here, just a second.
Should we just like leave the radical out of all of them?
Stop that. And then, get out of there. Why is that there? Okay. So here we go. Suppose f of x and g of x are inverses, like y equals the sine of x and y equals the inverse sine of x. Those are inverses of each other. Then if the point a comma b is on f of x, then the point b comma a must be on g of x. Because you know if a function has an inverse, then all the x's and y's are switched. For slopes, rise and run switch, so the rise of one guy is going to become the run of the other, and the run of one guy is going to become the rise of the other, because the x's and y's switch, correct? So are you okay that f prime of a, the slope of the derivative at the point x equals a, is going to be the inverse, because the rises and runs a switch, of g prime of b? It has to be g prime of b, because remember, the x and the y switched. So the derivative at this point, the cousin point, or the analogous point, let me get my thingy here. The derivative slope of the tangent here has to be the reciprocal of the slope of the tangent there. Slope of the tangent on the inverse function g of x has to be the reciprocal of the slope of the tangent at the original point on f of x, okay? So I'm now going to use functional notation. Generally, if the point x comma f of x is a point on f of x, then the x and y switch. F of x is going to be the new x on g of x, but the y, you don't have to call it x. You can also say it's g of this guy, so g of f of x. And so now instead of f prime of a, I'm going to have f prime of x, and instead of f prime of b, I'm going to have, or I'm sorry, g prime of b, excuse me, I'm going to have g prime of f of x. And so this ends up being the general relationship between a function, the derivatives of a function and its inverse. That relationship being f prime of x equals 1 over g prime of f of x. So now I'm going to plug in with my f of x being the inverse sine of x and my g of x being just the sine of x. They're inverses of each other. So I get that the derivative of the inverse sine of x is 1 over g prime of f of x. G prime of x is cosine of x, so I would have the cosine of f of x, which is the cosine of the inverse sine of x. And so looking at our little triangle, remember the inverse sine is just an angle, like 45 degrees or 30 degrees. So the inverse sine of x means I've got an angle here whose sine is x over 1. So if this angle is the inverse sine of x, that means the opposite side has to be x and the hypotenuse has to be 1. So that the sine of this angle ends up being x over 1. So this angle would be the inverse sine of x over 1. Well, if that's x and that's 1, then by Pythagorean theorem, that's the square root of 1 minus x squared. And so the cosine of that angle is the adjacent leg over the hypotenuse. So the cosine would be just radical 1 minus x squared. And there it is. And so this technique can be used to find the derivatives of all the other inverse trig functions. Whereas yesterday, the way I proved to you what the derivative was by doing implicit differentiation. I don't know if you remember, but I started with y equals the inverse sine of x, then I did the sine of y equals x, then I did the implicit derivative of both sides of the equation. But you don't even have to do implicit derivative. You can entirely use the facts about inverse functions. And so I just wanted to show you this, and the big thing I want you to get out of that is that there is a reciprocal relationship between the slope of the tangent of one function and the slope of the tangent of its sister point on the inverse function. And the relationship is that they're inverses of each other. Not negative inverses, they're not perpendicular to each other, they're just inverses because the rise and the line switch. Okay, hey, any questions or problems on this alternate way to derive the inverse sine of x? Yes? Sure. Scrolly, scrolly, scroll. Alrighty. Well, hey. Anything else on this? Then it is time for us to get the derivative of the v dx. Let me get this off here. Let me get this chair out of here. So I don't keep bumping into it. What the? Oh. Did my chair lose one of its casters?
Yep. Front one.
Stupid chair. It's like, this chair is impossibly old, so I couldn't buy any casters that actually fit. So I put a bunch of electrical tape on to make it fit, but I don't know if that's a real good fix.
Duct tape's better.
Well, yeah, I needed something that took up space so I could jam it in there.
Oh.
Maybe so I went with the electrical because it's a lot more elastic than duct tape.
Have you heard of easy fuse tape?
What, Tony, describe it to me.
It only bonds to itself.
Oh. That's weird. Then how do you dispense easy fuse tape if it adheres to itself?
You use a thin layer of plastic around it.
Oh, okay. Wow. That's really cool. Never heard
They use it for plumbing.
of it.
I've also seen people use it as a belt.
That's
You just cut it off.
pretty funny. Okay. All right. Let's go ahead and learn what the derivative of e to the x is. By the way, those of you who had Mrs. Lofgren last year, does anyone remember what the derivative of e to the x is?
It's e to the x.
How many people remember it's e to the x? Yeah, that's a beautiful thing about the derivative of e to the x.
It's e to the
So
x.
here we go. The derivative of e to the x, it just so happens that it's equal to e to the x, which would mean that the derivative of e to the u, where u is some function of x, the derivative of e to the u is just e to the u. Doesn't matter what's in the exponent. Derivative of e to anything is just e to itself, as long as there's x's there. Obviously, you tell me, what's the derivative of e squared? 0, right?
Yeah.
Because the derivative of a constant is always 0. So don't be thinking that if you have e to a constant that it has some weird derivative. The derivative of e squared is 0. But e to the u, the derivative of e to the u is just e to the u, except you must multiply by what the derivative of u is. That's the chain rule. Chain rule tells us that. Alrighty. Well, here comes the derivation of it. And I'd say, you don't have to write this down. I'm going to write it down as quickly as I can. Derivative of e to the x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. Right? That's our definition of the derivative. So now I'm going to stick in x plus h and x into the function. So I get e to the x plus h minus e to the x all over h. Okay, and now I'm going to split up that exponential. So I get the limit as h approaches 0 of e to the x times e to the h minus e to the x over h. You guys okay that when I have the product of two exponentials with the same base, I can just add the exponents? And so I can go the other way as well. And now I'm going to factor out e to the x. So I got the limit as h approaches 0 of e to the x times e to the h minus 1 over h. But it just so happens, if you were to put this on your graphing calculator and graph e to the x minus 1 over x, and then see what the graph does as x gets really close to 0, it turns out that this ends up equaling 1. There's other ways to show it equals 1. One way would be L'Hopital's rule, but we haven't learned L'Hopital's rule yet, so you would just have to graph it. If you graphed e to the x minus 1 over x and looked at the graph, you'd find that the graph gets really close to 1 when x gets really close to 0. So you end up with just the limit as h approaches 0 of e to the x, which is e to the x. Ta-da! So I hope you believe. So here we go. Please do this problem. Give me the derivative of e to the x squared. Good luck. I'll give you a hint. The derivative of e to the x squared is e to the x squared. It's that simple. Okay, good luck. Except, don't forget to multiply by the derivative of x squared. That tastes good. I don't know whose water it is, but it tastes really good, so I'm gonna keep it. Do you know what the name of your sub was yesterday?
Franz.
Mrs. Franz.
Mrs. Franz?
Yeah.
Cool. I don't know who she is. It was random. So is it spelled F-R-A-N-Z?
Yeah.
Was she nice?
Yeah.
Was
She's very soft spoken though. Yeah.
Good luck. Was she cute?
She was like, I think she was almost 70. I would say
70?
she's
Cool,
70.
cool.
Maybe she was 70.
She still had the blonde hair though.
Maybe she's 55, but she did a lot of hard living.
Very soft spoken.
Okay. Can I ask how many people got that as their answer? Yay. Okay. Okay, let's do another one. Let me see. Do I have any more to do, or should I just move on?
These are getting crazy, Mr. Shane.
This is pretty easy.
These are so hard.
Hey, try this. F of x equals
Oh.
x e to the sine of x squared. Do that one. Let's see if any of you guys can get that right. Or get F prime.
Come on, Mr.
Who's absent today? Jessica. All right, time's up. I mean, keep working if you want, but I'm gonna do the answer. Okay, did everyone get that so far? The derivative of the first times the second plus the first times the derivative of the second?
Yeah.
Good, so you should have what I have there. And now comes the task of getting the derivative of sine of x squared. Well, the derivative of the sine of anything is the cosine of that thing. I don't care what it is, except now I must multiply by the derivative of what you're taking the sine of. So there's my answer. So if you want to have your answer in a way that, that would be on the multiple choice portion of the exam, then you should get an answer that looks like this. Or if you want to check your answer on the back of the book. How many people got, wait, did I forget something?
You forgot to factor out e sine to the x squared.
What?
You forgot cosine.
Yeah.
Wouldn't
Hey,
you?
wait, what are you saying? E sine of x, oh, you want me
factor
to
it.
factor out e sine of x squared?
Isn't that what it would look like on the test?
No, it could be, you're right. But I'm not going to, but you're right, it could very well look right. How many people got that answer? Okay, yay, then I got it right and that's all I care about. Let's go ahead and do the next thing, the derivative of the log natural.
All the. What? Like drop water?
It turns out that the derivative of the log natural of x ends up equaling, do you guys remember? Anyone remember? What's the derivative of the log natural of x?
Isn't it just
No. Who said that? Zach, say that again? No, but you're close.
Oh, wait, no, it was
One
x
over
over.
x? Oh, it's just
Just 1 over x, that's all, just 1 over x. Derivative of the log natural of x is 1 over x, it's that
It's
simple.
the stuff
So,
in the parentheses.
if you got the derivative of the log natural of u, which is some function of x, some thing with a bunch of x's in it, then it's gonna be 1 over u, just like this, except you're gonna have to multiply by the derivative of u. You guys okay with that? I'm going to show you why really quick, just because I don't know, there's something inside me that makes me want to show you why it's true, even though I probably shouldn't go to the trouble. But here we go. Y equals log natural of x. I'm going to get the derivative here the same way I did the inverse functions. I'm just going to take the e to the power of both sides of this equation and then do implicit derivation, which is the way I showed you inverse sine cosine tangent on Monday. So I'm going to take implicit derivative. So first, take e to the power of both sides. So on the left side, I get e to the y, and e to the log natural of x is just x. And then I take the derivative of both sides of this equation, which means I get the derivative of e to the y is just e to the y, except I have to multiply by dy dx. And the derivative of x is 1. And so I get to dy dx equals e to the y. But e to the y is equal to x, right? E to the y is equal to x. So, wait, what have I done? 1 over e to the y. My bad. 1 over e to the y. And then e to the y is just x, so I get dy dx equals 1 over x. Ta-da. So, do you guys believe?
Yes.
Okay, good. Let's go ahead and do some problems. Here, okay, y equals log natural of 2x. I'd like everyone to please get me y prime now. Good luck. Okay, time's up. The derivative of the log natural of anything is 1 over that thing multiplied by the derivative of that thing. 1 over x. How many people got 1 over x? Yay, but I thought the derivative of the log natural of x would be 1 over x. Why would the derivative of log natural of 2x be 1 over x?
Wait, what?
Look, the derivative of the log natural of x is 1 over x. Why would the derivative of the log natural of 2x also be 1 over x?
Because you have to multiply by the derivative of the inside of the parentheses.
True. But what else do you notice? What's the relationship between the log natural of x and the log natural of 2x? That is, can I rewrite the log natural of 2x in a way that would make it very clear to you that the derivative was going to be 1 over x?
Yeah.
Yes?
It's-
Yes, Zach?
By natural log 2 plus natural log x.
Good, is that what you're going to say? Yeah. You guys okay with that? That the log natural of 2x is the log natural of 2 plus the log natural of x. That's one of the rules of logs. And then now when I take the derivative of the log natural of 2, hey, that's a constant, like 5 or 12. And the derivative of the log natural of 2 is 0. The derivative of the log natural of x is 1 over x. So that's why it happens that way. You guys okay with that? Okay, great. Okay, let's do another one. Yeah, here's a good one. The derivative of the log natural of the log natural of x squared. Good luck with that. Okay, the derivative of the log natural of anything is 1 over that thing. Okay, let's go for it. The log natural of, well, the derivative of the log natural of anything is 1 over that thing, correct?
Yes.
You guys okay with that?
Yeah.
The derivative of the log natural of that is equal to 1 over that.
Yep.
And now I have to take the derivative of that. So the derivative of the log natural of x squared, well, the derivative of the log natural of x squared is going to be 1 over x squared, except I have to multiply by the derivative of x squared, which is 2x. So my final answer ends up being one of the x's cancel. I get 2 over x log natural of x squared.
We should do a power rule.
How many people got that answer? Okay, many of you. Any questions or problems on this? Anything I did that doesn't make sense? Yes, Andrew?
If we were to take the second derivative, we would do the product rule, right?
Yes, sir.
Oh.
Well, actually, I would either product or quotient. I would probably do quotient rule.
Well, because if you just have the two, it's a constant, then you just do product rule in the denominator, I guess.
Yeah, but if you're gonna do product rule, then you'd have to bring this up as 2 times and then x log natural of x squared to the -1.
Oh.
Then you would just actually do general power rule,
Oh.
you know? But as long as it's a denominator of a fraction, really you would have to do quotient rule, not product rule.
Oh.
Any question or problem on this? Okay, hey, let me give you one more. E. What if y equals the log natural of x times x squared plus 1 squared
Oh, no.
over the square root of 2x to the third minus 1? Please write that down. Alrighty. So, this is easy, right? The derivative of the log natural of anything is just 1 over that thing. So all I have to do is put the reciprocal of it and then multiply by the derivative of this thing. Except I'd like you to notice, will taking the derivative of this be an easy task? No, it'd be horrible. I would have to do quotient rule, and within quotient rule, I'd have to do product rule and a couple of general power rules. This would be a bear. This would take me 5 or 10 minutes just to take this derivative. Gosh, so I refuse to do it. I'm not going to spend 5 or 10 minutes, and frankly, the answer is going to look awful. Gosh, I wish there was some way I could like simplify this, make it simpler. Yes, Chris.
You can do ln minus x times x squared plus 1 squared minus ln of the bottom.
Okay, say that again.
So
What?
you could subtract the ln's because it's you're dividing the two numbers. So you could do ln x times x squared plus 1 squared minus the ln of the bottom.
Okay, let's do what Chris says. We can split it up. We can say this is the log natural of x times x squared plus 1 squared minus the log natural of the square root of 2x to the third minus 1. Well, that helps. That makes it a lot simpler. But you know what Michael Jackson says, don't stop till you get enough, right? Is there more I can do here?
Yes.
What else can I do?
U x plus x squared.
Hey, beautiful, let's keep going. Let's have it be log natural of x plus log natural of x squared plus 1 squared minus log natural of, do you mind if I rewrite this as 2x to the third minus 1 to the 1/2 power?
Yes.
Do you mind if I do that rather than having radicals? Because I can't take square root of radicals. I can only take square roots of exponentials. Well, is there one last thing I can do to make my life easier?
Yes.
What's that, Andrew?
It's pull all the exponents of the to the front.
Pull all the exponents out front,
Yep.
right? Now this becomes 2 log natural of x squared plus 1 minus 1/2 log natural of 2x to the third minus 1. Have I made the problem easier?
Yes.
Way easier. Now this is trivial. Now suddenly it went from a problem that's going to take me 5 or 10 minutes to a problem that I can do in 10 seconds, right? So if someone gives you a log natural of a bunch of really complicated stuff, please simplify it. Simplify it, you know? And now I can go ahead and get the derivative. The derivative of log natural of x is 1 over x. The derivative of this guy is 2 times 1 over x squared plus 1 times 2x. And then I get minus 1/2 times 1 over 2x to the third minus 1 times 6x squared. And then I can, you know, I wouldn't try to add those fractions. I wouldn't try to get a common denominator and add them. Then I've just defeated the whole purpose of everything I did. So I would just keep my answer like this. Why try to combine these fractions? having the fractions be separated is just fine, you know? The 2 and the 6 cancel. So I got 3x squared over 2x to the 3rd power x. Yeah, hey, that's nice. I'm satisfied with that answer. You know, oh wait, let me, this is y, and so this is y prime. My bad teacher. I took the derivative of both sides of the equation to turn it into this. So it went from y to y prime. Okay, you guys okay with that? Okay, great. Well, let's move on to another type of problem. I'm going to skip this for a moment. I'm going to come back to this momentarily. But I want to talk about a process called logarithmic differentiation. It's a technique you use if you have a really, really complex function that you want to take the derivative of. Here, let me show you. Okay. Logarithmic differentiation for complex functions. I'm going to give you a function where it's going to be really complex. You're going to have to do a lot of product rule, quotient rule, general power rule stuff. It's going to be really tough. Y equals x times x squared plus 1 squared over the square root of 2x to the 3rd minus 1. This is going to be a real bear to get the derivative of. Does that function look familiar to you?
Yeah, it's the other one.
Oh. But you know what made this so easy was that there was a log natural in front of it. So I was able to split it up and do all that wonderful stuff. There's no log natural here. Yes, Daniel?
Let's put our own log natural.
Put your own log natural there?
Yeah.
You mean like the village people say, make real your dreams?
Yeah.
Yeah. You know that song YMCA? You can make
Oh.
real your dreams, but you got to know this one thing. No man doesn't live by himself. And young man,
Yeah.
put your pride on the shoulder. Please wait. But anyway, yeah, so that's what the village people say, and I always do everything the village people say. So let's do that. And that's the key to logarithmic differentiation. The steps. Number 1, take log natural of both sides. You are going to put that log natural there as Daniel recommended. So now I'm going to have the log natural of y equals the log natural of x times x squared plus 1 squared over the square root of 2x to the 3rd minus 1. Okay? And then step 2 is to separate and simplify the right side. That is, do this stuff. And if you don't mind, I'm just going to write it down because we already did it, right? So this becomes log natural of x plus 2 times the log natural of x squared plus 1 minus 1/2 times the log natural of 2x to the 3rd minus 1. And that's equal to the log natural of y. And then the third step is get the derivative of, get the derivative of both sides, solve for dy dx. So what's the derivative of the log natural of y?
1 over y times dx.
Beautiful, times dy dx. Derivative of log natural of anything is 1 over that thing, except I have to multiply by the derivative of that thing. Great. And then the right side, I'm just going to write down the answer because we already did it. 1 over x plus 2 times log, oops, plus 4x over x squared plus 1 minus 3x squared over 2x to the third minus 1. Yay. And what do you suppose the last step is? Or what should I do now?
Multiply both sides by y.
Yeah, multiply both sides by y, right? I'm going to multiply. Don't forget to do that. The most common mistake students make is they forget to multiply both sides by y. So I get dy dx equals 1 over x plus 4x times x squared plus 1 minus 3x squared, 2x to the third minus 1. And then, since we want our derivative to only be in terms of x's, we're going to write down what y actually is. So you end up going x times x squared plus 1 squared over square root of 2x to the third minus 1. And there's your answer. This is called logarithmic differentiation. It's what we do when someone presents us with something, a fraction in particular. When you've got a fraction with powers and product rule in it, why go through the hassle? Just do logarithmic differentiation, and now you're not having to think. The difficulty of the level of the problem plummets when you do logarithmic differentiation.
Who created it? Like, who
I
thought
don't
of
know. Yeah, well, who was the first guy to think of it?
it? Yeah.
Good question. I have no idea.
Because like we have all the rules from different people. I was
Yeah.
just wondering if this one had a name.
Yeah, no. I mean, its name comes from the technique rather than any human being, rather than from any dead white guy. Okay.
You know what gets weird?
Here.
Names.
Just a second. There was an example I wanted to give. I'm not going to give that
It's
example.
all the easy stuff.
Yeah.
I don't think it's complicated when they use
Y
names of people.
equals x squared plus 5 to the third power over the cubed root of x plus 1. Okay. Get y prime. Please do this problem using logarithmic differentiation. I just made that problem up in my head. Take log natural of both sides, separate and simplify the right side, and then get the derivative of both sides. After your simplification, you should have something that looks like this. By the way, how many people are able to go do it in one step where they go directly from here to there? Oh, wow, okay, you guys are really smart. You guys are good at algebra, that's good. Yeah, that's what I do. And now let's go ahead and get the derivative. And let's see what you guys got. All right. Hey, how many people got that answer? Okay. How many people were able to get that answer and do the problem entirely in their heads? Hey, let's see you do this one. Here, do this one in your head. If you can do this one in your head, you win. Here is x to the third plus 5x over x minus 5 squared. Go ahead, get me y prime right now. All of you kids who can do this in your head, get me y prime.
I'm not cheating. I never cheat. I have never cheated.
That's x to the third plus 5x. May not look like a 3 from there. Alrighty, all you do it in your head, people. Let's see if I get the same answer as you. So I got, 1/3 times 1 over x
Mr.
to the
Shana.
third. What?
It's 1/2.
Oh my God. Other than that, I was going to do, well, I messed it up. I was thinking of this stupid problem. Oh my God. Okay, well, 1/2. I'm not going to get it right now, but because I got it wrong. But that's okay. And then what is that? 3x squared plus 5. Okay. Minus 2 times over x minus 5. And then radical x.
I wrote it down as I got it in my head.
I did that.
Did anyone get that answer? Okay, you guys are all do it in your head, people. Good for you guys. Okay, let's do our second to last one, our penultimate situation, which is anything to the u power. And then I'm going to come back and get the derivative of log base a. Alrighty, so logarithmic differentiation for, I'm going to put a big X through that and put anything to the u power. Because when you're presented with some weird thing to the u power where it isn't specifically e, then you're going to use logarithmic differentiation as well. Okay? So let me give you an example. If I gave you y equals e to the x squared plus x power, you could get the derivative really easy. Y prime equals e to the x squared plus x power, right? Because the derivative of e to anything is just itself. That was easy, except don't forget to multiply by the derivative of x squared plus x. So this is multiplied by 2x plus 1. Okay, great. But what if I gave you this? Y equals 2 to the x squared plus x power. Now, you don't get to do that just let it equal itself thing, because that let it equal itself thing only works when e is the base, not when anything else is the base. So what I recommend is logarithmic differentiation, because it works for anything else besides e. What I would do is take the log natural of both sides of the equation. Okay, then bring that exponent out. X squared plus x, whoops, yeah, times log natural of 2. You guys okay with that? And this is still log natural of y. And now I'm going to take the derivative of both sides of the equation. So I get 1 over y times dy dx equals. Do I have to do product rule here?
Yeah, no,
Why not? Why don't I have to do product rule?
because natural log of 2 is a constant.
Yeah, natural log of 2 is a constant, no product rule required. So I just have to get the derivative of this, which is 2x plus 1, and then the log natural of 2 goes out front. It's just a constant, like 5 or 12. Okay, and now I multiply both sides by y. I get dy dx equals the log natural of 2 times 2x plus 1 times y, which is e to the x squared plus x.
It's just, oh, okay.
Yes, what?
No, because the step above it, you didn't have the parentheses, and so I was confused if it was
Oh,
supposed to be in it.
yeah, I should have put, I mean, I don't need the parentheses,
Oh,
but
yeah.
I don't know.
You put it in the second one, it's fine.
Yeah.
Shouldn't
Oh.
it be 2?
Wait, what?
2 to the x squared plus x.
Oh, yes. Oh, my gosh. See, I'm distracted now. I'm just all distracted. Okay, thank you. Thank you, Justin. Yeah, that's a 2. That E didn't magically turn, I mean, you know, the E did, this 2 didn't magically turn into an E. Oh, I see. I got confused. I looked up here and saw that E instead of that 2. Yeah, that's what happened. I got confused.
Corn?
Okay, let me show you another one. What if I gave you this? This is number 2. What if I gave you y equals x raised to the tangent of x power, and I wanted the derivative of that? Well, again, if you've got any exponential, I don't care what the base is, if the exponent is a function of x, you should do logarithmic differentiation. So in this case, I'm going to take the log natural of both sides of the equation. And do you mind if I just do that simplification immediately, like that? The log natural of x tangent of x is going to be tangent of x log natural of x. Are you okay with that, or should I show you? Because I took the tangent of x and put it out front in one step. So now, am I going to have to do product rule here?
Yes.
Yeah, now you got to do product rule. I didn't have to do product rule when the base was just a number, but when the base is also a function of x, you're going to have to do product rule. So yeah, so I get 1 over y times dy dx equals the derivative of the tangent of x, which is the secant squared of x, times the log natural of x, plus the tangent of x times the derivative of the log natural of x. Okay? And now I'm going to multiply both sides by y. So I get dy dx equals secant squared of x log natural of x plus tangent of x over x multiplied by x to the tangent of x. You guys ready to do a couple of these on your own?
Yes.
Good. I saw a thumbs up. Jacob gave me a thumbs up, and it's good enough for me. Here it comes. Oy. Do 3, oops, y equals 3 raised to the x to the 3rd power. And then number 2, y equals, what should I have here? Well, let's go sine. Okay, good luck. Get me y prime of both of these. 3 to the x to the 3rd power and sine of x to the x squared power. Please do logarithmic differentiation of both of them. look at number 1, you should have got that answer.
Why'd you separate the 3 and the x squared?
I don't know. That's a good question. Normally, textbooks, they like, if I have, you know, I don't know, they like to have the numbers, like the normal numbers way out front, and then the x's way at the back, and then everything else in between. I don't know, that's what books do. So they would not
Easy.
express their final answer like 3x squared log natural 3. They would tend to put the log natural 3 out front, but then the 3 goes to the left of the 3 log natural 3. So it looks like that. I don't know. Books do that, but obviously I would accept any correct answer. I don't care. You know. Yeah, isn't that weird? I was wondering why I did it that way. It's just I was trained by all the textbooks I've ever used. I mean, because it doesn't matter. But they like to have the x's at the very end. Okay, hey, let's do this because I'm running out of time. So you see log natural of y equals x squared log natural of the sine of x. And so I get 1 over y dy dx equals 2x log natural sine x plus x squared 1 over sine x times cosine x. You guys okay with that? Derivative of log natural sine of x is 1 over sine x times the derivative of the sine of x. And so I get dy dx equaling 2x log natural sine x plus x squared. How many people have called cosine x over sine x cotangent x? That's fine. The little book would probably do like 1 over tangent x, but whatever. Cotangent x is fine. And then sine x dx squared. How many people got that answer? Okay, good. Then I think you're good on logarithmic differentiation. There's one more thing I need to show you. Although, was there any questions or issues on that problem? Then one more thing I got to show you. Taking the derivative of a log with a base other than e. And I don't really have to teach you. My answer is turn it into a log base e. Because we have a general formula, and that general formula is that the log base a of b equals the log natural of b over the log natural of a. So what you're going to do is if you have a log with a base other than e, go ahead and just turn it into a log base e. So for example, if I wanted the derivative of the common log of x squared, let's say, where, well, let's just make common log of x. I'm not going to mess around. Okay, then the first thing I'm going to do is rewrite this as the log natural of x over the log natural of 10. You see that? So now I've turned it into a log natural. It used to be a log base 10. Now it's a log natural. Now I can get the derivative of log natural, have 1 over the log natural of 10 times 1 over x, and then there's my answer. So you're going to encounter some problems on tonight's homework. And just remember, if they have a log with a base other than e, go ahead and turn it into a log with a base of e. All right, good luck, you guys.